Hello, this is my third video from section 10.1. And so the question is, when is it a left-tailed or a right-tailed or a two-tailed test? And then the next question might be, what does that even mean? So what we're going to talk about here is, this is part of finding the p-value. So the p-value, what that means is the probability of getting the observed data under the assumption that the null hypothesis is true, whatever the null hypothesis is. So suppose we observe, we collect a sample and our sample mean is 30. I don't even know what the data is. Don't worry about that. This is what we have observed. This has really happened. Now the probability of x bar equaling 30, remember that sample means are normally distributed, which are continuous. This is virtually 0. Let's have a look. Sample means are normally distributed. So suppose this is where 30 is on this drawing. It has no width whatsoever. Don't forget that what we want to know is actually the probability of x being 30 or all events even more extreme. And what is meant by that? Well, we look to the alternative hypothesis to see what we're looking for. We're looking for events that are even further away from our null hypothesis. So if the alternative can only be one of three things: less than, greater than, or not equal to. The only three symbols that don't contain an equality. So let's start with, if the alternative hypothesis is that, in this case it's a mean, it's not just a generic parameter because I'm testing it with a sample mean. If the true mean is less than some value, then it's a left-tailed test. And I'm looking at what's the probability of getting a sample mean of 30 or all the data values even smaller than 30. And this is called a left-tailed test, and this is the probability I'm looking for. That's my p-value. Okay, let me erase the screen just a little bit. Okay, I'm going to regret erasing that normal distribution. It was quite a good normal distribution for me. But anyway, so now again, I'm not looking at the probability of x bar being exactly 30 if my alternative hypothesis is that mu is greater than some value. This inequality, you can think of it as an arrow pointing in the direction of the tail. This is a right-tailed test. And so in this picture, now I'm trying to find the probability of my p-value is getting an x bar that's greater than or equal to 30. And that area there is my p-value. And if my alternative hypothesis, here's the last possible choice, is that the mean is not equal to 30. Now values even more extreme are in either direction. So here's 30, and I'm going to look at all the data that's greater than 30, but I'm also going to go, here's the mean. Oops, mean is not very straight. I'm going to go out, whatever this distance is, I'm going to go out the same distance the other way and put in another boundary there, and I'm going to look at values even further away from the mean in the other direction. And so this is what we mean by a two-tailed test. And now I'm looking at the data in both tails. All of this area plus all of this area, that's my p-value. So in short, if you're trying to decide if it's a left-tailed, right-tailed, or two-tailed test, what you're going to look at is you're going to look at the alternative hypothesis, and it's going to help you. Either it's going to point in the direction of the tails. If it's not pointing in any direction, it's because it's both tails. It's a two-tailed test. It will be your calculator that, for the most part, will help find the p-value for you. Okay, so that's all I've got on this video.